Hello and welcome to Mrs. Law's class. In this video, I'm going to show you how to solve quadratic equations by factoring. Now, in order to do this, we need to know something called the zero product property. And the zero product property states that if the product of two real numbers is zero, then one or both of those numbers must be zero. So that should make sense. So if we have a times b and that equals 0, then we know that either a equals 0, because a 0 times b equals 0, or we can say that b equals 0, because a times 0 is still 0, or perhaps both of them, a and b, both equal 0. All right, so we're going to use this zero product property to solve these questions here by factoring. So these first two questions that I have here, they're already in factored form. So we can say that this is kind of like our a, the x minus 2, and the x plus 7 is our b. So we know that these two binomials are being multiplied and they equal 0. Because it equals 0, we know that either x minus 2 equals 0, or x plus 7 equals 0. So solving this little equation, we have x equals 2. And solving the second little equation, we have x equals negative 7. So our two solutions are 2 and negative 7. And you can plug them in to check. So if we plug in 2, we get 2 minus 2, and that's going to be 0. And 0 times whatever is on the other side will still be 0. Same with negative 7, we plug that into x. Negative 7 plus 7 is 0. So anything times 0 is still going to equal 0. All right, let's go on to the second one. So we know this first binomial is equal to 0, or the second binomial equals 0. So we have 2x minus 3 equals 0, or we have 3x plus 1 equals 0. So again, we can solve each of these little equations independently. So we have 2x equals 3, divide both sides by 2, so x equals 3 over 2. Second one, we get 3x equals negative 1, and then x equals negative 1/3. So you're going to get quicker at this, that you're going to notice a pattern, that you don't have to maybe solve this little equation, but you'll actually know what the answer is just from looking at the factor form. Because you can see here, x is 3 over 2, and to cancel off the 2 that's already there, this has to be 3 over 2. The 2's cross off, and we have 3 minus 3. So I can show that to you by substituting this in. So the 2's would cross off, so you have 3 minus 3, and that gives you 0. And then we can do the same thing with the negative 1/3. All right, for the last 4 questions, or the next 4, we have to actually do some factoring. So we should always find the GCF first. And in question C here, we can see that the greatest common factor is 8n. So once we factor 8n out, we're going to have left n minus 5 equals 0. So every time you see a variable, we have 8n here, either that's going to equal 0, or the n minus 5 equals 0. So we have 8n equals 0. Divide both sides by 8, so n still equals 0. We have n minus 5 equals 0, so n equals 5. All right, we can start to do this a little bit quicker. So let me just circle the last answer here. Okay. All right, so here we're going to factor. We want two numbers that multiply to 25 and adds to negative 10, and that would be x minus 5 and x minus 5, and that equals 0. So here we have x equals 5 and 5. Now you don't have to write them both twice, because since they're the same, we can just write x equals 5. All right, so for the next one here, we need to move everything to one side first before we can factor. So we're going to get 3x squared minus 2x minus 8 equals 0. And then I'm going to actually factor this by kind of doing a crisscross guessing and checking method. So I know that the numbers that multiply to 3 are 3 and 1, okay? And then the numbers that multiply to negative 8 are negative 4 and 2, or 4 and negative 2. Now, knowing that I want to get negative 2 here, I know that 4 has to be on the top, 2 has to be on the bottom, because when I crisscross, this will give me 6, and this will give me 4. Now, because I know that I want negative 2, I want the bigger number of these multiplications, so is going to be negative. So that has to be negative 6, because 4 plus negative 6 is negative 2. So knowing that this is negative 6, then this back number here has to be negative 2. So this gives me 3x plus 4 as one of my factors, since we have this. And then my other factor is going to be x, and then minus 2. And that equals 0. All right, so we can do a quick solving here. I'm going to skip these steps that I did above here. And I know that x equals negative 4/3 and positive 2. Now, if you're not sure how to factor, you can go and watch one of my other factoring videos on how to factor. All right, in this last question here, like the other one that we just did, we need to move all the terms to one side. So I'm going to move the negative 1/3 x squared to the left and set this equal to now 0. And notice that all the questions that I've done here, all of them have to equal 0 before I can actually factor. All right, now I'm going to multiply both sides by the GCF, which happens to be 3 because it's my only denominator. And the reason I do that is when I multiply, that denominator disappears. So I get x squared, and then 3 times 8/3 is 8x. 3 times 5 is 15. And then on my right side, 0 times 3 is 0. And then I can factor. So this will be x plus 5 times x plus 3. And that all equals 0. And then solving, this will give me negative 5 and negative 3. So notice that these answers are going to be the opposite sign of what the factor is. Because when you plug it in, negative 5 plus 5, again, is going to give you 0. And negative 3 plus 3 will also give you 0. All right, I'm going to do one more example, and we're going to take a look at a word problem here. So here's a common one. Where you see two numbers, they differ by 6. If the numbers are squared and then added, the result is 146. So what are the numbers? All right, I'm going to first write a let statement so that we can identify the variable that I'm using. So we're going to let the first number, since it says there are two numbers, the first number, we don't know what it is, we're going to call it x. The second number, so since it says here that two numbers differ by 6, we know the other one is either going to be x minus 6, or you can also use x plus 6. So you decide which one you want to do, okay? So what I'm going to do is I'm going to use the x minus 6, and it says here that if the numbers are squared, so I'm going to square each of these numbers that I have. So x squared and x minus 6 all squared, and then we add them together. The result is 146. Okay, so we're going to go x squared, and then now remember that x minus 6 all squared means x minus 6 times x minus 6. Now if you want to skip this step, you can, if you know how to multiply the x minus 6 all squared in your head. So this will be x squared minus 12x, because we have negative 6x, and another negative 6x in the middle, plus 36 equals 146. All right, so let's collect all our like terms and move everything to one side so that the equation equals 0. So we get 2x squared minus 12x, and then 36 minus 146 is negative 110 equals 0. Now this seems like a really big number to factor, but you'll notice that all of these numbers are divisible by 2. So I'm going to factor out the 2. Now, I can actually either factor out the 2, like I'm going to do here, x squared minus 6x minus 55 equals 0. Or you can actually think of this as dividing everything by 2, because 0 divided by 2 will give you 0 anyway. So we actually don't really need that coefficient 2 in the front. But you know what? I'm going to leave it. And I'm going to factor this trinomial. And two numbers that multiply to negative 55 and adds to negative 6 are negative 11. And then x plus 5 equals 0. So now my two solutions here are x equals 11 and negative 5. All right, so how does this work? Because I have two values of x. So in this case, we actually have two solutions, okay? So when I plug in the 11, actually I'm going to erase this one here because I didn't use it. I can either say x is 11, and if x is 11, then we also have here 11 minus 5, and that equals 6. Now we can also say, I'll use a different color, we can also say that x is negative 5. So we can say that this is negative 5. And then we can also say negative 5 minus 6, which equals negative 11. So I actually have two solutions here. So the numbers are 11 and 6, or we can also have negative 5 and negative 11. And that's how you solve a word problem.